welcome to the deep dive. Today we're looking at how modern fiber optics is giving old-school video tech a massive second life.
It really is.
We're doing a deep dive into this Thor Broadcast kit, the F-1HD-1D-TVI-TXRX, and we're trying to answer a pretty core question.
Which is?
How do you send crystal clear 1080p video, say 20 kilometers, without having to rip out your entire existing analog system?
Right. And I think the real insight here is the economic strategy. This kit isn't really about some revolutionary new video standard.
No.
It's all about infrastructure preservation. The source material keeps saying this unit is the key to making legacy analog systems still relevant.
So you're saving a facility from what, a multi-million-dollar camera replacement?
Exactly. You just leverage a cheap, really robust transport layer, which is fiber.
Okay, so let's unpack this analog system rescue mission a bit. The core tech is HDTVI, transport video interface.
Right. They call it the new analog.
An open platform.
Yeah.
But how broad is the backward compatibility? Because for a big installation, I mean, that's the real deal breaker.
It's extremely broad, and that's its power. It supports the major legacy players, AHDH, AHDM, HDTVI, HDCVI.
And all at 720p and 1080p?
Both. And critically, the spec sheet guarantees the 1080p version is explicitly backward compatible with older 720p cameras and even the really old analog ones.
So you keep the cameras you have.
You keep the cameras, you just get this amazing fiber transport.
And crucially, you don't lose quality to get that massive reach. I mean, they're using BNC connectors, which is great. You don't have to rewire every camera.
Right.
But how can a system like this actually guarantee pristine 1080p video across that kind of distance?
They do it with a couple of specialized techniques. First is 10-bit digital video encoding.
Okay, what did that mean in simple terms?
It just means they aren't losing the crucial color depth or dynamic range just to, squeeze the signal onto the fiber.
Got it. And the second thing?
They use something called uncompressed transmission technology, or CRFT. It ensures the video stays high def without the usual degradation you'd get from compression over a long haul.
So the encoding keeps the quality pristine. But, pristine quality is useless if the signal dies after 300 meters.
Which is the kiss of death for 1080p on standard coax cable.
Exactly. So what does fiber change about that fundamental limit?
Oh, fiber changes everything. Coax, like you said, it maxes out at maybe 300 meters for 1080p.
Maybe 500 for 720p if you're lucky?
Yeah. This Thor kit, it delivers that same video 20 kilometers. And the specs even mention optional versions pushing that out to 80 kilometers.
80. That's a monumental leap.
It is. And it's just by changing the medium from copper to light.
That distance is amazing, but let's talk efficiency. The spec sheet says this kit uses single-mode simplex fiber.
It does.
Wait, simplex. That means just one fiber strand? How did that even work?
That's the really clever part. Using a single strand is a huge cost saving on installation. They do it with something called wavelength division multiplexing, or WDM.
So different colors of light on the same strand?
Basically, yeah. The transmitter sends on one wavelength, say 1310 nanometers, and the receiver sends control data back on a totally different one, like 1550.
All down the same tiny piece of glass.
All at the same time.
And for the people actually installing this, the genius is the simplicity.
Absolutely. It's truly plug and play. The spec sheet is clear. No electronic or optical adjustments needed in the field.
And they seem to be guaranteeing resilience, too. Using high-quality components, SMT.
Surface mount technology, yeah. So it's not built with cheap, unreliable parts.
What about uptime? They mentioned a really good mean time between failures.
They state an MTBF of over 100,000 hours.
Okay, so for a facility manager, what is that in real terms?
That is roughly 11 years of continuous operation. They're promising enterprise-level reliability without that enterprise price tag.
A commercial-grade solution bridging old BNC video right into the future of fiber.
That's it, exactly.
And that brings us to our final thought for you to consider. If a mature technology like HDTVI can get such renewed life just by changing the transport medium, what other technologies, ones you might see as legacy right now, are just waiting for a foundational shift like fiber optics to completely revolutionize their capabilities?
Yeah, what's next?
That's something to mull over until our next deep dive.